This video will give examples with the natural logarithm. Evaluate for x. E to the negative x equals 2. We can take the natural logarithm of both sides, which means we can bring down our power. Now then, ln of e is simply 1. So we have negative x equals ln 2, or x equals negative ln 2. And using our calculator, we can find that this is equal to negative 0.69. Here we have ln of x equals 0.35. We can rewrite this in exponential form. E to the 0.35 equals x. And so now we can just evaluate this with a calculator. And we end up with 1.42 about. Evaluate e to the power of ln 4.9. Here we have the inverse property of logarithms, so that tells us that our answer is just equal to 4.9. Evaluate ln of e to the 3.8. Again, using an inverse property of logarithms, we can simply say that this is equal to 3.8. Another way to see this is using the power rule. We can bring down 3.8, leaving ln of e, and since ln of e is just equal to 1, we just have 3.8 times 1, which is the same thing as what we found using the inverse rule. Solve. Negative 2 e to the 5x plus 10 equals 6. So I'm going to start by subtracting 10. So I end up with negative 4. Now I'll divide by negative 2. And at this point, I can just put this into logarithmic form. So the log base e of 2 equals 5x plus 10. And we'll rewrite log base e as ln of 2 equals 5x plus 10. So now we'll use a calculator to evaluate ln of 2. That's equal to about 0.69. So 5x plus 10. Continuing, 0.69 minus 10 is equal to 5x. So x is equal to 0.69 minus 10, and then we'll divide that by 5, which is about negative 1.86. Solve. ln 3x plus 2 is less than 5. So I'm going to raise e to the power of both sides. And now using the inverse property of logarithms, I'll have just 3x plus 2 on one side and e to the 5 on the other. So then 3x is less than e to the 5 minus 2, and x is less than e to the 5 minus 2 over 3. We can evaluate this with our calculator. And so we end up with x is less than 48.8. At this point, we should check to make sure that if we plug in 48.8 into our original equation, we don't end up with something negative here, because you can't take the logarithm of a negative number. And indeed, our solution works fine. Solve e to the 2x plus 3 plus 10 is greater than 4. So I'll subtract 10 from both sides, get negative 6. Now I'm going to take the natural log of both sides, and in this way I should be able to make the right hand side 2x plus 3, and then the left hand side should be the ln of negative 6. But recall that we can never take the natural log of a negative number. So really, we can't do this. In this case, what do? We can just think about the problem graphically. E to the power of x has a graph that looks like this. And so just looking at this, we can tell that no matter what x is, this value will always be greater than negative 6, meaning that our solution for this equation is that 2x plus 3 is anything. In other words, x is anything. So we can plug in any number into this inequality and it will hold true.